This is a calorimetry problem where we have two things that are changing heat. We start with a hot piece of iron that's at 101.0 degrees C, and we start with a water bath that is at 21 degrees C. We put the hot iron into the water. The iron's going to decrease in temperature. The water's going to increase in temperature so that they're both at the same final temperature, which in this case is 24.3 degrees C. So what we see, we have two different delta T's. We have a delta T for the iron, and we have a delta T for the liquid water. In each case, we know that delta T is going to be equal to the final temperature minus the initial temperature. Looking at iron first, we have the final temperature is 24.3 degrees C. The initial temperature is 101.0 degrees C. So the delta T for the iron is actually going to be a negative value. It's decreasing in temperature. And the value actually comes out to be minus 76.7 degrees C. Now for water, we still find delta T as TF minus TI. The final temperature is 24.3. The initial temperature is 21. So we have a delta T for water as a positive 3.3 degrees C. So now we have delta T for the water bath and the delta T for the initially hot piece of iron metal. We can apply the first law of thermo. The first law states that the energy of the universe is constant when applied to calorimetry, means that the heat gained plus the heat lost sums to 0. In this case, we see that the water bath is gaining heat, it's increasing in temperature, and the piece of metal is losing heat, it's decreasing in temperature. The heat in each case refers to the heat involved in the temperature change, which we know is going to be the mass times the specific heat times the delta T. Now, this is going to apply to two different situations, the water bath and the metal. So the water bath has a mass of 100 grams. Its heat capacity, we're going to use calories, is 1.000 calories per gram degree C, and the delta T, as we said, is 3.3 degrees C. We're going to add that to the heat involved with the metal changing temperature. And here we have the unknown mass of the metal and its heat capacity in calories, and this is iron, is 0.1078 units or calories per gram degree C. And our delta T, as we've determined below, is negative 76.7. And these sum to 0. Now, numerically, this calculation here comes out to 330. And to that, we're going to add the mass multiplied by the product of these two numbers, which is going to be a negative 8.268, and these sum to 0. So we're going to solve this equation for m. We see that m times minus 8.268 is going to be equal to a negative 330, and therefore m is going to be equal to a minus 330 divided by a minus 8.268. This is just simple algebra. And we calculate this out, and we find that m is mathematically equal to 39.91 grams. This is our calculator answer. We'll go back and determine sig figs. And it looks like we're going to be able to only justify 2 sig figs. So the answer comes out to be 40.0 grams.